Hello PU2 champions, so your second pre-board are coming, and in this video we are going to do the most important questions of a very important chapter, that is amines. So in my previous class I have already done the one shot revision, so please go through that video, revise all your concepts and then come back to this video to solve the questions. Okay, and these are most important questions because they are sourced from your PYQs model question papers and from the PU2 question bank released in 2026. Okay, so this video is going to be super important, and if you watch this one video and solve all the questions, then this chapter is done for you. You don't have to refer to any other source. So let's get started and see the very important thing, that is the blueprint of this chapter. So this chapter carries a total of 7 marks. Okay, you can see here the 1 second. Okay, so the chapter carries a weightage of 7 marks. There will be 2 1-marker question and 1 5-marker question. So here you will get 5 marks and here it is 2 marks, so total 7 marks. Okay, so now let's start with the previous year question. So I'll go from 2025 to 2022. Okay, so let's see the recent year 2025 question. The hybridization of the nitrogen atom, okay, in trimethylamine is. So all the ammonia and its derivatives are sp3 hybridized. So here the correct answer will be option number A. Next, ammonolysis of alkyl halides has the disadvantage of yielding a mixture of primary, secondary and tertiary and quaternary ammonium salts. Now the tertiary amine is obtained as a major product by taking large excess of ammonia in the ammonolysis of alkyl halides. Now see here, when you take excess of ammonia, quaternary is the major product that is formed, okay, not the tertiary one. And statement 1 is correct. So statement 1 is correct, but statement 2 is incorrect. 1 second, that will be your option number D here. Now moving to the 5-marker question in this particular section 2025 paper, describe the carbyl amine reaction with a suitable chemical reaction. Now carbyl amine reaction, you know, when you treat primary amines in presence of chloroform, it gives you isocyanides, and this is also used as a test for your amines, primary amines, right? So let's see and how to write this answer. So I'll just change the color of the ink. Now you can see when primary amine is heated with chloroform and alcoholic KOH, it gives you isocyanide, and this reaction is called as carbyl amine reaction. You can see here RNH2 plus CHCl3 plus KOH gives you RNC plus KCl plus water. Next question, explain the conversion of aniline to benzene diazonium chloride with the chemical equation. So if you have aniline and if you treat it with nitrous acid, it gets converted to benzene diazonium chloride. So aniline is converted to diazonium chloride by treatment with nitrous acid. So here you can see this is the formula of aniline, Na, NO2 and HCl. This together will react to give you nitrous acid. At a temperature of 273 to 278 Kelvin, you will get benzene diazonium chloride, NaCl and water. Now coming to the third question, among aryl amines and ammonia, which is more basic? Now see, what do you mean by the property of basicity? Basicity is the ability to donate electrons, right? Now what happens in case of aryl amine? We'll take the example of aniline. Okay, so if you see the structure of aniline, it is like this. Okay, now the lone pair of electrons here is involved in resonance. Okay, the lone pair of electrons is not available for donation. It is involved in resonance in the ring. So that is why the basicity of aryl amines is less than ammonia. So ammonia is more basic, as in aryl amine the lone pair of electrons on nitrogen is involved in resonance and is not available for donation. Now coming to the next one, PYQs of 2024 March, we will see, to prepare para-nitroaniline as a major product from aniline, the amino acid, the amino group is protected by. So if you have remembered, when we do, for example, if I take normal aniline, okay, and if you do nitration, for nitration we need concentrated HNO3 and H2SO4. Right, so I'm just revising the reagents here also. Now if you treat it, if you do nitration, what will happen? Here we will have NH2, and we have observed that we will get all the 3 products. Okay, you will get ortho product, and you will also get meta product, and you will also get the para product. Okay, here obviously the question comes that why we get the meta product, and the reason being that in such an acidic medium the NH2 group becomes protonated and then it becomes deactivating group, and that is why we also get almost 47% of the meta product. But the question is asking that if I want only para nitro group, then what you need to do? First you need to protect this one. For that, what we do, we can treat it with CH3COCl and Al. Just if you do acylation, what will happen? Here we will get NHCOCH3, and after that, when you treat it with nitration, that is concentrated HNO3 and concentrated H2SO4, then what will happen? Nitration will take place at the para position. Okay, so you will get a product like this where you have NHCONH3, and here we have the nitro group is attached. And after that, if you do hydrolysis H3O plus, then this group gets converted to NH2. So basically the protection is done by the what it is called acetylation. Okay, this group addition is called as acyl group addition or acetylation. Next question, the reagents used to separate the mixture of methylamine and dimethylamine. Now if you see methylamine, the structure is CH3NH2, right? And if I say dimethylamine, it is CH3NHCH3, right? So this is a secondary amine and this is a primary amine, and this can be separated using your I can say okay, so here we have all the reagents are very, I'll say little bit on the confusion side. So first of all, if you see CHCl3 with HCl, no, we use chloro. This is the carbyl amine reaction, and this uses your the first thing, that is alkaline medium, not HCl. Okay, so this one we can eliminate. Next is C6H5SO2Cl and KOH, and here we have C6H5SO2Cl and HCl. Again, here also we don't need HCl. First the salt will form, and the salt has to be soluble in alkali. So now B and D both can be the answer here, because this one will give you the carbyl amine reaction and this one can be found out by Hinsberg reagent. So the answer here will be both B and D. Okay. Now moving to the theoretical question of 5 marker in 2024. Write the chemical equations involved in the Gabriel thalamide synthesis of methanamine. This is very repeated, predictable and important question. So please prepare this mechanism thoroughly. Next is explain the coupling reaction of benzene diazonium chloride with phenol using the chemical reaction. So if you see first one, thalamide reaction, here it is shown for methanamine. I am just showing you the general reaction. You have to write for methanamine. Okay. So first you have to take thalamide, then you have to treat it with KOH. So what will happen here? This one will behave as an acid and donate H plus, and here a salt will form like this. Now here RX is taken. Here, because you want to prepare methanamine, here you should take one carbon group like this, CH3Cl. Okay, now what will happen? This N minus will attack on this one and KCl will be formed as a byproduct. So here you will get, in place of this R, you will get like NCH3. Okay, and after that, if you do just I'll say if you just treat it with NaOH, this bond will break and you will get here CH3NH2 as a product will be formed. Okay, now let's see the next question, that is 42B. Explain the coupling reaction of benzene diazonium chloride with phenol using chemical reaction. So this will produce para hydroxyazobenzene. So you can see here, when benzene diazonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with diazonium salt to form para hydroxyazobenzene. Okay, this is the reaction that you have to write down. Now coming to the 2023 March question, nitration of aniline in the strongly acidic medium at 288 Kelvin yields. Okay, now if you do nitration of aniline, you will get all the three products just now we discussed. So option number D is the correct answer. Next question, write the equations of a reaction involved in the Gabriel thalamide of primary amine. This we have already discussed. Complete the following reaction by giving the major product. Okay, so C6NH2 with NaNO2 and HCl. This is your diazotization reaction. So the product formed here will be nothing but your benzene diazonium chloride. Okay, next, benzene diazonium chloride and aniline in H plus medium, that will give you para aminoazobenzene. So here the structure will be like this. You have N, double bond N, and then you have a structure like this, and here we have NH2 group attached. Okay, now coming to the next question, 2023 May paper, the hybridized state of nitrogen in trimethylamine is, okay, hybridized state. So that is your sp3, option number C here again. Next question is explain Hoffman bromamide degradation with an equation. Now this is important question. So see, if you treat any amide using Hoffman bromamide degradation, the reagent for this one is Br2 in presence of NaOH. Okay, so if you treat any kind of amides with Hoffman bromamide degradation reagent, that is Br2 and NaOH, the amide will be reduced to give you an amine with one carbon less than the original reactant. Okay, so you can see here how we can write amides on heating with bromine and aqueous NaOH give primary amines having one carbon less. So you can see RCONH2 with Br2 and NaOH will give you RNH2 plus NaBr plus Na2CO3 plus water. Okay. Next, how do you convert the diazonium salt solution into iodobenzene and give equation? For iodobenzene, what you have to do? You have to take benzene diazonium chloride and treat it with Ki. Okay, then you will get iodobenzene. Remember the reagent required here, that is Ki. Next, what is the IUPAC name of this compound? So you can see it is N,N-dimethyl methanamine. Okay, N,N-dimethyl methanamine. Now coming to 2022 March PYQ, complete the equation. So you have here, this one has to be group is treated with HNO2, right? So if I treat CH3NH2, okay, with this one nitrous acid, I'll get CH3CN2 plus and Cn minus. Okay, you have to check here that there is two carbon, right? So this one has to be your two carbon, not one carbon. So this one will be CH3CH2NH2, right? Now when this one is treated, you will get CH3CH2N2 plus Cl minus. And okay, I think there is a small printing mistake here. This C will not be there. Okay, so my first answer would be the correct one. I'll just erase this one. See here, this is a small printing mistake here. This carbon is not there. So this one will be CH3OH. Okay, and when you treat it with, sorry, CH3NH2. Okay, now when you treat this one with nitrous acid, you get CH3N2 plus and Cl minus, and on hydrolysis you will get CH3OH plus N2 plus HCl. Okay, now coming to the next one is question number 2. Explain the carbyl amine reaction. Again, this question we have discussed. How aniline is prepared from nitrobenzene. Okay, so nitrobenzenes can be reduced using FeHCl, SnHCl, or simple hydrogen palladium to get you. So nitro compounds can be reduced to amines using these reagents. So you have to write that reaction. Give the IUPAC name of trimethylamine. So it is N,N-dimethyl methanamine. Okay, so when primary amines is heated with chloroform, so this is your question number 2. Already we have discussed, so I'm not just going to again talk about it. Next, the nitrobenzene is reduced to aniline using hydrogen, nickel, palladium, or using SnHCl or FeHCl. Next, you can see here example. You can take nitrobenzene with hydrogen, palladium, or with SnHCl or FeHCl. Next, give the IUPAC name of trimethylamine. Here the structure is like this: NCH3, CH3, and CH3. Okay, so this one will give you N,N-dimethyl methanamine. Okay, so that is N,N-dimethyl methanamine. Now coming to PYQs of 2022 July, how is methanamine prepared by Hoffman bromamide degradation? Write equation. This question we have already discussed. Okay, but yes, you have to write the exact reaction. For that, you see, you are going to prepare methanamine, right? If you are preparing methanamine, then the product is having only one carbon. That means reactant should have at least two carbon. So what should be the reaction here? So you have CH3CONH2. Okay, and if you treat this one with Br2 NaOH, okay, then this CO group will be reduced and will be removed, and you will get CH3NH2, which is your methanamine. Now coming to the next one, that is question number 4 here. What is the product formed when aniline is heated with chloroform and ethanolic KOH, and write the equation. This is again your carbyl amine reaction. Here the product you will get will be benzene isocyanate. Next, explain the coupling reaction of benzene with phenol. Again, this question also we have discussed. And next is write the IUPAC name of the given compound. So it is N,N-dimethyl ethanamine. Okay, so you can see the first one product will be phenyl isocyanide, and here we have the reaction. I'll just write this will be the C6H5NC will be your final product here. B question we have already discussed, but again I'll show you. With benzene, diazonium chloride and phenol, you will get para-hydroxyazobenzene. Next, the IUPAC name of this compound will be NN-dimethyl ethanamine. Okay, now we are done with the previous year questions. Now we will be talking about the questions that have been given in the question bank released by PU2 board for 25-26. Okay, so let's see all the questions from question bank here. I have taken almost all the questions. I have not missed even a single question here. So please watch it carefully. The first question is discussed about the bond angle and the hybrid orbitals of nitrogen in amines. First of all, the hybrid orbitals here used is sp3. And what is the bond angle? See, if you have a normal tetrahedral structure, in that case the bond angle is 109 degree. But in case of ammonia and its derivative, here there is lone pair, right? So if lone pair is there, there is repulsion. There is repulsion between this bond pair and lone pair, and because of this repulsion, what happens? The bonds come slightly closer to each other. Okay, now if the bond comes slightly closer to each other, the structure somewhere becomes like this, and this will be around 108 degree. Okay, or you can simply write down less than 109 degrees. So I'll show you how to write down. So answer has to be right. And okay, just a minute. Nitrogen has sp3 hybrid orbital. The bond angle is less than 109 because the lone pair bond pair repulsion is there. Next, name any one biologically active compound, okay, which contains used in the following to increase the blood pressure and as an anesthetic in dentistry. Now let me tell you that this question has been asked in MCQ, has been asked in KCET so many times. So please remember this properly. Okay, this is going to be a very important question. So first of all, increase the blood pressure. Here we have adrenaline and ephedrine, and next one is used as an anesthetic, that is your Novacin. Okay, now coming to next question of classification. What are simple amines? And write one example. So if all the R groups in an amine is same, then we call it as a simple amine. So amines are said to be simple when all the alkyl or aryl groups are the same. For example, N-dimethyl methanamine. If you write a structure like this, CH3 whole 3N, then it is a simple amine. Next, write the structures of all the isomeric amines having the formula C4H11N. Okay, this is a very important question. You should be writing all the possible. So you have to go through, like, first you write all the primary amines, then you write all the secondary amines, then all the tertiary amines possible. Okay, now let's first talk about the primary amines. So one can have, we can have, if you have all the carbons in one chain. Okay, next you have 4 carbons in one chain, but NH2 group is on the second carbon. Here IUPAC name is butane 1 amine. Here the IUPAC name is butane 2 amine. Now here what we see, 4 carbons are in one chain. Now let's change that to 3 carbons in one chain. So you can see if you have 3 carbons in one chain and then you have 1 carbon and 1 NH2 group as a branch structure. So here you will have 2 methyl propane 2 amine. Okay, and next you can also have the same structure where NH2 group is attached to the first carbon and the address remains same. So here the name will be again 2 methyl propane 1 amine. So these are all the possible structures for primary amines. Now if you move to secondary amines, you can have like group here 2 carbons and here 2 carbons, total 4 carbons are there. So you can have N-ethyl ethanamine. There's another possibility, one side you have 3 carbon, one side you have 1 carbon, then it is N-methyl propanamine, right? Next, okay, here. Now moving to the next one, if you see, you can have the one side a 3 carbon chain, but that is a branch one isopropyl group on one side and a normal methyl group on the other side. So you can have this one N-methyl propane 2 amine. Now the last structure that is possible is the tertiary one, where you can have N-dimethyl ethanamine. Okay, so total we can produce almost 8 structures here. Now moving to the question number 5 here, classify these into primary amines and secondary amines, aniline and diethyl amine. Now if you see aniline, the structure is like this, right? So nitrogen is having only 1 carbon group, so this is a primary amine. Now you have diethyl amine as well. So if you see diethyl amine, the structure is like this. Okay, now if you have diethyl amine, this is a secondary amine group. Now coming to the next one, nomenclature, write the IUPAC name for the given compounds. Okay, so first one you can see you have a structure like this, CH3, CH3, CH, NH2, right? So you can write this structure like this: 1 2 3 propane to amine. Okay, and the next structure, if you see this side, it is a secondary amine, and this side it is a primary amine. So it is like 2, this I'll name it like this: 1 2. So 2, you can see dimethyl amino ethane 1 amine. Next one, write the IUPAC name of the following compounds: M-bromo C6H4NH2. So it is 3-bromo-aniline. And then you have C6H5NHCH3. So the structure of this one is like this: NHCH3. So this is N-methyl benzenamine. Now write the IUPAC name of the simplest aryl amine and what is its formula. So it is aniline, and the formula is, with a benzene ring, you can have one amino group. Now moving to the next question, question number 9. Write the chemical equation for the reaction between ethane nitrile and sodium amalgam in ethanol. So ethane nitrile with sodium amalgam will give you again amine, okay, or I can say ethanamine. So I'll just write down this reaction here. So you need ethane nitrile, right? So it is CH3 C triple bond N, and if you treat this one with sodium amalgam and ethanol, okay, so this will produce alkyl amine, or I can say ethanamine. Next, reduction of amides using lithium aluminium hydride. So RCONH2 with lithium aluminium hydride will give you RCH2NH2. This CO group which is present, right, I'll just mark it. See, this CO group is converted to CH2 group. Now let's see the 10th question here. How is aniline obtained from nitrobenzene? Okay, aniline from nitrobenzene. So if you just reduce nitrobenzene with FeHCl, SnHCl or hydrogen palladium, you will get aniline. Next, write the chemical equation. So you can see this reaction is there. Nitro compounds are reduced to amines by passing hydrogen gas in finely divided nickel, platinum, or by reaction with metals in acidic medium. Next, question number 11, give reason here. Reduction of nitrobenzene with iron scrap and hydrochloric acid is preferred. Name the organic compound which is formed as the product formed in the reaction. Now this question is very, very important, that why do we use this metal with HCl in this particular reaction, especially Fe is preferred here. Okay, so the reason for that is, see, reduction with iron scrap and hydrochloric acid is preferred because FeCl2 is formed as a byproduct, okay, and this FeCl2 gets hydrolyzed to produce back HCl, which is used in the reaction, right? If you see, HCl is required in this reaction, so when you use Fe, what happens, you get a byproduct FeCl2, and then when this FeCl2 reacts with water, or you just hydrolyze it, you will get back your HCl, which can be used in this particular reaction. So that is the story of using FeHCl, and that is why it is preferred. So what is the byproduct formed here? FeCl2. Now question number 12 is, write the chemical equation for the reaction of chloroethane with ethanolic ammonia. Okay, so chloroethane, if you take, that is chloroethane, okay, with ammonia. Okay, so here first what will happen, one of the hydrogen will be replaced with the alkyl group. So what I will get, CH3 CH2. So here basically what happens, this nitrogen attacks on this one, and then the salt type of compound is formed. So CH3 CH2 NH3 plus and Cl minus, a salt like this is formed, and then when you treat this with NaOH, you will get here NaCl plus water, okay, and then you will get CH3 CH2 NH2. Now in the question, if it is mentioned with excess of ammonia or with excess of CH3 CH2 Cl, then again you can do reaction till the quaternary product is formed, but here there is no mention of that, so only you have to write this much reaction. Next, question number 13 is, let's see what is there in question number 13. Ammonolysis of 2 moles of benzene chloride. Okay, just a minute. Okay, fine. Okay, this is actually answer number 13. Okay, here there's a small, okay, I'll write answer number 13 again here. Let's do it. Answer number 13. What is saying? Write the chemical reaction for the ammonolysis of 2 moles of benzyl chloride. Okay, so if you have 2 moles of benzyl chloride, C6H5 CH2Cl, okay, that is benzyl chloride, and if you treat it with first ammonia, then what will happen, you will get a compound like this, CH2NH2. Now again, if you treat this one with C6H5 CH2Cl, what will happen, H HCl will be removed and H will be replaced with this particular group. So you will get C6H5 CH2NH CH2C6H5. Okay, so this will be the product formed here. Now for answer number, this is for answer 13. Answer 14, how does 1 mole of benzyl amine reacts with 2 moles of chloromethane? Okay, if I see answer 14, you have 1 mole of benzyl amine. So let's write like this. Again, benzyl amine is like this. Okay, reacts with 2 moles of chloromethane. So first let's take 1 mole. Okay, so HCl will be removed from here and you will get a product like this, CH2NH. Okay, one hydrogen is replaced with CH3 group. Then again if you treat it with CH3Cl, okay, then hydrogen will be replaced again here and you will get a product like this, CH2NCH3CH3. Okay, now moving to question number 15. Answer number 15, how is benzamide converted to aniline? Okay, so benzamide, if you see, the structure is like this. Benzamide structure is NH2. How it is converted to aniline? So you can see in the product the number of carbon is less than one less than the reactant. So that means we have to remove this CO group, and for that you need Br2 with NaOH. Okay. Now that is your 15th answer. Moving to question number 16 here. Explain Hoffman bromamide degradation by taking butanamide as an example. This we have already discussed. I'll just show you the reaction here, okay, because we have taken for a general reaction. So CH3, CH2, CH2, CO, NH2. Okay, and if you treat this one with Hoffman bromamide degradation, that is Br2 with NaOH, so this CO group will be removed and you will get CH3, CH2, CH2, NH2, right? That is your propanamine. Next, how is methanamine prepared from Hoffman bromamide degradation? So you see, again, this question also we have discussed. In methanamine there is 1 carbon, and if you are using Hoffman bromamide degradation, that means in the reactant there has to be 2 carbon. So you have to take ethanamide with bromine and NaOH. So that is CH3CO NH2. Okay, and here if you treat it with bromine and NaOH, what will happen? This CO group will be removed and I'll get CH3NH2. Okay, next question number 18, write the equation. Okay, write the equation for the reaction of an amide with bromine and ethanol to give you primary amine. This is again Hoffman bromamide degradation and the name of the reaction. We have already discussed this question. Now explain carbyl amine reaction. This also we have discussed this question with an example. Question number 20. Aromatic primary amines cannot be prepared by Gabriel phthalimide synthesis. Why? Okay, this is important question. Now if you have remembered Gabriel phthalimide method, okay, I'll just go back to the question where we have discussed the Gabriel phthalimide one, so that I can explain you exactly what happens in the, like, why we cannot use aryl amine. Just give me 1 second. Where is that question? Yeah, you can see here. Now see, I'll just clear the screen so that you will be able to understand it in a better way. See what happens. You see here what happens, this Rx group is there, this nitrogen attacks on this R and this X group moves out, right? So what is happening, this Rx bond should break. Okay, and if you have an aryl amine in place, for example, if you have the NH2 group here, sorry, chlorobenzene, you have this one, and we have studied in haloalkanes and haloarenes chapter that this bond has a partial double bond character. It is attached to an sp2 carbon, so this bond will not break. That means the nitrogen lone pair cannot break this group, and that is why we cannot produce aryl amines using this particular method. Okay, so now let's go back to our question, which was, I think, just a minute, let me open this one. Yes, okay, I think next question was this one. Yeah, question number 20a. Aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution reaction with the anion formed by phthalimide. Whatever anion is formed, that cannot attack on the haloarene to give you a salt. Okay, so that is why this reaction will not take place. Next, question number 20b. Write the equation for obtaining methanamine from CH3NH3 whole plus. Okay, so you have this one reaction, CH3, and then you have NH3 plus X minus, and if you treat it with NaOH. So what will happen? First NaX will form, okay, then you have H2O, okay, then you have CH3NH2. Okay, so that is all about this reaction. Next, coming to question number 21 here. Okay, just a minute. Okay, 24, and simple amine X, okay, with the formula C4H11N consumes 2 moles of chloromethane per mole of amine to form a quaternary ammonium salt. Write the structure of the IUPAC. Okay, write the structure and the IUPAC name of this isomeric amine X. Now, what is this saying? The simple amine X. Simple amine X means all the R groups are same. Okay, with the molecular formula C4H11N consumes 2 moles of chloromethane. If it can consume 2 moles of chloromethane, that means this must be a secondary amine. Why? Because see, when it consumes first mole, it will give you a tertiary amine, and after that on the second mole, it will give you a quaternary mole, right? To give you a quaternary ammonium salt. So secondary amine with this formula C4 is there. So I will have CH3, CH2, then I have NH, and then I have again CH2, CH3. Okay, so this is going to be the formula of the compound, and its IUPAC name you can easily write. It is N-ethyl ethanamine. Okay, now question number 22, write the chemical equation for the preparation of aniline from benzene. Okay, so how I can prepare? So I'll just note down the answer 22 here. Okay, how to prepare aniline from benzene? Just I'll go to the next slide. Yes, aniline, how to prepare aniline from benzene. So first you can have benzene, then you can have nitrobenzene. Okay, and once you got nitrobenzene, you can reduce this one to aniline, right? So here I just need to fill the reagents now. So benzene to nitrobenzene, we need concentrated HNO3 and concentrated H2SO4, right? Then once we have got nitrobenzene, we can reduce it using SnHCl, FeHCl, or hydrogen palladium, right? Moving to question number 23 here. Let's see. Ethyl amine is soluble in water, whereas aniline is not. Justify the statement. So the solubility depends on the R group. If the R group is big, the solubility will be less. So that is the reason here. Ethyl amine is soluble in water because it has a small hydrocarbon group and forms strong hydrogen bonds with water. Aniline contains a large hydrophobic benzene ring, which reduces the hydrogen bonding with water, making it insoluble. Okay. Next, question number 24, arrange the following in the increasing order of their boiling point. So for boiling point, remember, more the hydrogen bonding, okay, more hydrogen bond, you will have more boiling point. So let's see here. First you have alcohol, you have secondary amine, and then you have primary amine. So primary amines can form more hydrogens bond because they have more hydrogen than secondary than tertiary, right? So boiling point order is like this: primary, secondary, and tertiary. So here you see alcohols generally can form better hydrogen bonding because of the higher electronegativity of oxygen. So alcohols will have the highest boiling point, then the primary one, and then the secondary one. Next, here also we have a similar question. You can see hydrogen bonding depends on the structure. Smaller the structure, better is the hydrogen bonding. Here you can see this is primary, this is secondary, and here we have a bulkier group. So that is why C2H5NH2, then you have secondary, and then you have a bulkier group which reduces the solubility because of less formation of hydrogen bonding. Now let's move to question number 25 here. Between aryl amines and ammonia, which is more basic and why? Already we have discussed this question. Ammonia will be more basic, okay? Ammonia will be more basic because in aryl amine, the lone pair of electrons is involved in resonance, okay? So I have already discussed, I'm not going to talk about that question again. Next, pKb of aniline is more than that of methanamine. Now see here, if something is more basic, okay, if it's a strong base or more basic, then pKb will be less, okay, and less basic means pKb will be more. So if pKb is having more, pKb of aniline is more than methanamine, that means methanamine is more basic than, so that means what? Methanamine, okay, methanamine is more basic than I can say aniline. And I think all of you can guess the reason for this. Again, in aniline, the lone pair of electrons are delocalized and are involved in resonance, okay. Aniline is less basic than methanamine because the lone pair of electrons on nitrogen in aniline is delocalized due to resonance. Hence, its pKb is more. Now coming to the next one, question number 27. Answer, arrange the following. Okay. In the decreasing order of pKb values. Decreasing order of pKb values. That means highest pKb, or that means least acidic. Okay. So here you can see that least acidic, first of all I have this group, then I have this group. Whenever I have an aromatic group, that will decrease the basicity, and here also I have one aromatic group. But here you see that there is this CH3 group which will actually donate electrons to the nitrogen by its plus I effect. Okay, so if I compare this structure and this structure, this will be least basic, and this one will be more than that. So if this is least basic, then its pKb value will be highest. So this one will be highest. After that, we will have this one. Okay, and if you compare these two structures on the basis of inductive effect, the order of basicity is 3 degree, 2 degree, 1 degree, right, in gaseous phase. So this is 2 degree and this is 1 degree. So that means this one will be least basic or high. After that, 3 will be the basic on the, like, in the decreasing order. So the pKb value will be higher. Then here we will have this one. So you can see the order. First we will have, so the question has asked us in the decreasing order of pKb. So I think this order we have to change it. See, decreasing order will be for this one. Okay, highest pKb, sorry, yes, decreasing, the this one is same, only have to just change the symbol. Decreasing order of pKb. See, this is least basic, so it is having the highest pKb. Then this is the least basic. After that, so after pKb will come for this one, then this one, and then lastly will be this one. This is highly basic, so strong base, so it will have the least pKb value. Next, in the increasing order of basic strength should increase. Okay, basic strength should increase. Again, you can see here that this is a 2 degree, so it will have the highest basicity. This is 1 degree, then this one will have. And if you see these two compounds, okay, here both of them are having the aryl group, so they will be less basic than the aliphatic group. But here we have two CH3 groups which can donate electrons, right? So that is why that will increase the basicity, and C6H5NH2 will have the least basicity. Okay, now coming to question number 28, how do primary aliphatic amines react with nitrous acid, and write the equation here. Now primary aliphatic amines reacts to give you alcohols, to form a, first of all, a very unstable diazonium chloride, which eventually converts to alcohols and with the elimination of nitrogen gas. Okay, so they form nitrogen gas and alcohols. You can see the reaction here. So you'll get a first an unstable benzene diazonium chloride, which reduces to ROH plus N2 plus HCl. Okay, next moving to question number 28. How do primary aliphatic amines reacts with nitrous acid? This we have already discussed. Write the chemical equation for the reaction between ethanamine and benzene sulfonyl chloride. So ethanamine is a primary amine, right? So when it reacts with benzene sulfonyl chloride, it will give you a salt which is soluble in an alkali because it has an acidic hydrogen. So this is benzene diazonium chloride and this is ethanamine. Sorry, this is benzene sulfonyl chloride. So from here this HCl will be removed and you will get a compound like this called as N-ethyl benzyl sulfonamide, and this is soluble in alkali because of this acidic hydrogen. Now moving to question number 30, write the equation for the conversion of aniline into 4-bromoaniline. Okay, so this is again very good question, because if you directly do bromination to aniline, you will get 2, 4, 6. All the orthopara positions will be substituted. But if I want only para-aniline or 4-bromoaniline, then first you need to protect the amino group and then you have to deprotect it. So how will you do that? So first we'll take benzene and then you have to just treat it with anhydride or any acyl chloride, and you just need to acylate this group. Okay, now once you have done the acylation, then you treat with bromine with acetic acid. Bromine will be added at the para position, and then again to deprotonate it or deprotect it, you can use OH minus or H plus. Okay, that will deprotect you and you will finally get 4-bromoaniline. Okay, next, between ethanamine and trimethylamine, which one does not react with Hinsberg reagent? Give reason. So to react with the Hinsberg reagent, the amine must have one hydrogen. If you see trimethylamine, the structure is like the CH3 whole 3N, right? In trimethylamine, there is no hydrogen. There is no hydrogen present in the amine group, so it will not react with benzene diazonium chloride, or sorry, it will not react with benzene sulfonyl chloride, or commonly called as Hinsberg reagent. Now, next question we'll see 32 here. NN diethanamine answers to Hinsberg reagent but is insoluble in alkali. Why? Now, this is a secondary amine, right? So, it has an hydrogen which can react with benzene sulfonyl chloride. But once the salt is formed, there is no more acidic hydrogen left. So, that is why it will not further react with the alkali, and that is why it is insoluble. So, you can see here when NN diethanamine reacts with benzene sulfonyl chloride, N-N-diethyl benzene sulfonamide is formed. Since N-N-diethyl benzene sulfonamide does not contain any hydrogen, this is the main point. For attached to the nitrogen atom, it is not acidic and hence it is insoluble in alkali. Now coming to question number 33, how is aniline converted into sulfonilic acid? Write the chemical equation. So first aniline is treated with concentrated sulfuric acid. This is base, this is acid. So there's a salt type product is formed. Then at a higher temperature, there is an exchange. And finally, proton exchange takes place to give you this type of compound here. Next question number 34, identify compound X and Y in the following conversion. Okay. First NaNO2 and HCl. This is the, I can say, what I'll say. This is diazotization. So X we will get here is this one like this. N2 plus and Cl minus. Now after you treat something with that, you get a iodobenzene. So what will happen? Y will be converted, or you will get Y if I treat it with Ki. Okay, so sorry, the product I have written, it has to be what? It has to be Ki, right? Okay. Next, how do you distinguish between primary, secondary, and tertiary amine using Hinsberg reagent? This is very important question. So first of all, I will write, see, with Hinsberg reagent, what happens? Primary amines will form an alkyne benzene sulfonamide, which is soluble in alkali. Secondary amines will give you N dialkyl benzene sulfonamide, which is insoluble in alkali. Tertiary amines have no reaction with Hinsberg reagent, and by that way, we can distinguish them. Next is explain Hoffman bromamide degradation, already explained many times. Which of the following amine reacts with para-toluene sulfonyl chloride to produce a sulfonyl amide which is soluble in alkali? So that means they are talking or asking about the primary amine. So this trimethylamine is the tertiary one, dimethylamine is the secondary one, and ethanamine is the primary one, right? So it is ethanamine. Now question number 38 here, write the equation for the preparation of the following with nitrous acid. Aromatic primary amines, aliphatic primary amines. Okay, so you have to prepare, if you take, if you want to prepare aromatic primary amines, okay, and you have to use what? Nitrous acid. So let's see here. Write the equation for the reaction of the following with nitrous acid. So when you have aromatic primary amines, okay, this one, aromatic primary amine, I'll write one here, that will give you benzene diazonium chloride. And if you have aliphatic, or I can say aliphatic amines, primary amines, that will give you alcohol. Okay, please remember this one, very important question. Next, what is the equation for the preparation of para-hydroxyazobenzene? This is again coupling reaction. We have already discussed this question. Next is coupling reaction with chloride and aniline. So this one is also coupling reaction. How do you convert benzene diazonium chloride to para-aminoazobenzene? These all questions are from coupling reactions and we have discussed all of them. Okay, you can see once again on the screen. Now moving to question number 42 here, write the chemical equation for the reaction of para-hydroxyazobenzene from diazonium salt. Again the coupling reaction. What is the color of the dye formed? This is important for the hydroxyazobenzene. This one, this is an orange dye. Okay. Next is explain Gattermann reaction for the preparation of bromobenzene. Now once you get benzene diazonium chloride, if you just use copper powder with HCl or HBr, that is called as Gattermann reaction. Okay. Chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt with corresponding halogen acid and the copper powder. Okay, example you can see, if you have this benzene diazonium chloride and you are treating it with copper HCl or copper HBr, and then you can still get chlorobenzene or bromobenzene. Now coming to question number 44, one second. How does benzene diazonium chloride reacts with ethanol? Write the equation. So see, benzene diazonium chloride will react with ethanol to give you phenol. Okay, it will produce OH group for you. So that is why, no, one second. Yeah, ethanol will give you OH group, that is phenol will be the product here. Next question number 45, write the equation for the conversion of benzene diazonium chloride into benzene. If you want to convert benzene diazonium chloride to benzene, you have to treat simply it with water. Okay, so you can see, okay, I think one mistake I did here. This question with ethanol, right? With ethanol, you will get this one as benzene, not phenol. Only H will be produced here. Okay. Next question, here you can see with benzene diazonium chloride, if you just want benzene, then you can treat it with H3PO2 and water, or simply ethanol will work here, okay, to give you H. Next is question number 46. Identify compound X and Y in the following conversion. Okay, here this is X and this is Y. This one we have already discussed. Here you will get benzene diazonium chloride. Okay, so X will be something like this, N2 plus and Cl minus. Okay, and then once this is done, Y will be Ki. Okay, and that will replace this one. Next C6H5N2 with HbF4. So I'm writing the answer for 47 here, so that I have some space. Okay, so see here, first of all, when you treat it with this one, what you will get? You will get a compound like this, N2 plus and BF4 minus. Okay, and then once you treat it with NaNO2 and Cu, okay, if you treat it with NaNO2 and Cu, you will get something like this. That is, here you will get NO2 group, okay, and here you will get, sorry, no more benzene ring. Okay, so this N2 group will come out, that will give you nitrogen, and okay, this one will give me, when I treat it with NaNO2 and Cu, that can give me here NO2 group, right? Nitrobenzene will be produced and you will have a byproduct of BF3. Okay, now let's see the next question. Now we'll talk about the 3-marker questions here. Okay, write the chemical equation involved in the preparation of aliphatic primary amine in Gabriel phthalimide synthesis. Already we have discussed this question. Write the chemical equation for Gabriel phthalimide. Again we have discussed this question. Hoffman bromamide degradation, this also we have discussed. Okay, next question number 4, mention any 3 factors which decide the basic strength of alkyl amines in aqueous solution. Yes, here we have 3 important factors. One is your inductive effect, steric factor and solvation effect. Okay, so these are the 3 factors which affect the basicity of amines in aqueous medium. Next, what is Hinsberg reagent and how do you distinguish between primary, secondary and tertiary? This also we have already discussed. Next, aniline on acetylation followed by nitration and hydrolysis gives para-nitroaniline as the major product. Write the equation involved. So first of all, aniline is taken, then you have to protect the aniline group. After that, nitration is done, so at the para position nitro group is attached, and then you have to do deprotection to give the NH2 back. Next, question number 17, identify A, B and C. So this question we have just solved. So you can see, first of all, here I will get a I can say benzene diazonium chloride. Then HbF4, what it will do? It will give us a product like this, where I have N2 plus and BF4 minus. Now after that, when you treat it with NaNO2 Cu and heating, here what I will get, the main product is your nitro group, NO2, and then some byproducts are also formed here, but this is the major product here. Write the chemical equation for preparation of cyanobenzene from benzene diazonium chloride. So you can treat it with benzene diazonium chloride with Cu, Cn, KCN, then you will get cyanobenzene. Reduction of benzene diazonium chloride to benzene. Okay, simply to reduction to benzene, you can treat it with ethyl alcohol. Next, conversion of benzene diazonium chloride to phenol, you have to treat it with water. Okay, so I will just write down this like this. So I'm writing at the center. If you have benzene diazonium chloride and you want to treat it with CuCN and KCN, okay, that will give you the first one, that is cyanobenzene. Okay, this is number 1 question. The second one is when you treat it with, I want to get benzene from here, and for that you need to treat it with ethyl alcohol. Okay, and then you have to treat it with phenol to get phenol. Okay, so here I can treat this with water to get phenol. Okay, next we'll see question number 9, that is Which type of amines answer for carbylamine reaction? Okay, primary amines. Okay, and describe the carbylamine reaction with a suitable example. Okay, already we have discussed, and you can see the reaction like this. Identify A, B, and C. First, you have taken CH3. There's a CN group, cyanide group, and partial hydrolysis. So A will be something like this. You have CH3, CH2, then you have CONH2. On partial hydrolysis, you get amines. Next, with NaOH and Br2. Okay, if you treat it with NaOH and Br2, this is Hoffman bromamide degradation, and you will get one carbon like this, that is ethanamine. Next, when you treat it with nitrous acid, okay, and this together can be written as nitrous acid, so that will be giving me alcohol, that is CH3 CH2OH. Okay, so what is C here? Ethyl alcohol. Question number 11. So these are now your case based, or I can say word problem based question. So you have to be very careful here. So, okay, let's solve this one. First question, an aromatic compound A is there. Okay, on treatment with aqueous ammonia, followed by heating, forms a compound B. Okay, treated with aqueous ammonia followed by heating gives you compound B. Now the compound B on heating with Br2 and KOH is given. I have written NaOH, sorry, KOH gives you compound C with the molecular formula C6H7N. Okay, write the IUPAC name of A, B, and C. Now see, this from the reagent bromine KOH, you can easily identify that this has to be Hoffman bromamide degradation. And C6H7N, this structure is nothing but your aniline, right? This has to be aniline. Now, if this one is formed from this particular compound B, then B has to be a amide, that is CONH2. If this is there, and if you now treat it with Hoffman bromamide degradation, this CO group will be removed and you will get a compound like this. After that, aqueous NH3 and heating. So this compound has to be a acidic group. Okay, when it is treated with ammonia and heating, we get amides. Then on treating amides with bromine and NKOH, you will get aniline group. Now moving to question number 12 here. An amine A is there which can be prepared by Gabriel phthalimide synthesis. That means this is a primary amine. Compound A reacts with nitrous acid, okay, to give organic compound B. The functional isomer of B is this one. So okay, B isomer is what? CH3OCH3. Okay, that means what? See, if you see ether, alcohols and ethers are functional isomers. That means this has to be one alcohol group and it has to be CH3CH2OH. Okay, if this is this one, then primary amine will be what? CH3CH2NH2, right? That has to be A. Next, A reacts with nitric acid to give you B. The functional isomer of B is given. The compound A can be prepared by the reduction of amide C. Okay, so now if I reduce amide C, so if I have like this CH3CONH2, and if you treat it with lithium aluminium hydride, then you will get CH3CH2NH2. So this is compound C here. The compound A can be prepared by the reduction of an amide C. So identify A, B, and C. So we have already identified A is nothing but CH3CH2NH2. Okay, and on treatment with nitrous acid, it gives you compound B, which is an alcohol, that is CH3CH2OH. Then C has to be the CH3CONH2 group. Now let's see question number 14 here. Okay, a hydrocarbon A is there whose molecular formula is C4H8, which on treatment with hydrochloric acid, okay, gives a compound B with molecular formula C4H9Cl. The compound B reacts with 1 mole of ammonia, okay, which to give you a compound C. Now the compound C reacts with nitrous acid, okay, reacts with nitrous acid followed by water to give you an optically active alcohol. Okay, the ozonolysis of A gives 2 molecules of acetaldehyde. Ozonolysis of A gives you 2 molecules of acetaldehyde. Okay, that means this one. So I think we can very easily now predict what is A. See, if you remember, when you have any ozonolysis, if you have a structure like this and this breaks, here you have to add an oxygen and here you have to add an oxygen. So if you are getting two molecules of acetaldehyde, that means it is a symmetrical alkene, and A is nothing but CH3 CH double bond CH CH3. Okay, now if you treat it with HCl, then what will happen? HCl will be added. Here it is a symmetrical alkene. So you will get a compound like this. Okay, this is compound B. Now when you treat it with ammonia, okay, you will get what? The compound C, what they have told you, compound B reacts with 1 mole of ammonia to give you compound C, right? And compound C, so similarly the Cl will be replaced with NH2 group. So I will get CH3 CH2 CH NH2 CH3. Now if you treat this one with what? Compound C reacts with nitrous acid. Okay, so nitrous acid means this NH2 group will be converted to OH group. So you will have a structure like this. Okay, and now there is one special thing about this compound D, that this is an optically active alcohol, right? Optically active means all the four groups should be different. So you can see this particular carbon is a steric carbon or it is an asymmetric carbon, so it is optically active. Identify compound A, B and D. So A is my but 2-ene. Okay, what is B here? B here is 2-chlorobutane, right? And this one, that is C. C is here butane to amine, butane to amine, and lastly D is butane to alcohol or butane to OL. Okay, so students, now I'll just show you the model question papers. Actually all the questions in the model question papers are from your question bank only, so we have discussed all of them. So let's just talk about MCQs, and the 5 marker questions are all covered. The reaction of aniline which produces zwitter ion as the major product here is, so one second, so zwitter ion is produced during sulfonation, so option number C here. Which of the following groups at para position increases the basic strength? So it should be an electron donating group. So here NH2 is an electron donating group. So that will increase the basic strength of the aniline. Next we have this question, which of the carbylamine already we have discussed, and this question also we have discussed. Moving to model question paper 2, consider following reaction. RCONH2 plus Br2 plus NaOH gives you this product. If the molecular formula of an amine is CH5N, okay, then the molecular formula of the amide will be, okay. Now see, if the amide will have definitely one carbon more, right? So if here it is C, one carbon C is, then in the reactant there will be two carbon, right? So which all options are having two carbons? This is having one carbon and this is having this two carbon. Next you need this NH2 group remains the same, okay, so that means the R group, okay, so if I have this particular compound CH5N, okay, the amine formula, then it must be CH3NH2, right? That means what will be the reactant here? It has to be CH3CONH2, right? So I need C2H5 and O, right? C2H5 and NO. So that is your option number B here. Next, Gabriel is used for the synthesis of primary amines. Next, carbylamine we have already discussed. This reaction also we have discussed, and IUPAC name of this one is very simple. It is butane 1-amine. Okay. Now moving to model question paper 3, Hinsberg reagent formula is C6H5, sorry, C6H5SO2Cl, and color of para-hydroxyazobenzene is orange. Okay, and then Hoffman bromamide we have discussed, coupling reaction we have discussed. Here there's a question to find the what is it, to find the IUPAC name. Okay, so for that this is NN dimethyl and this is present in butane 2-amine, right? So you can write down NN diethyl butane 2-amine. So students, these were the most important questions from PYQs and model question paper. Now I'll be giving you a list of top questions that you should definitely prepare from this chapter. So question number 1 is the coupling reaction, preparation of para-hydroxyazobenzene and para-hydroxyaminobenzene. Okay. Next question, pKb of aniline is more than methenamine. This is very important question. That is because of the lone pair of nitrogen is delocalized. Next, Gabriel phthalimide synthesis, carbyl amine reaction. These two are very important question. Then arrange the following in the basicity order for aqueous medium especially. You should prepare thoroughly. And then what is Hinsberg reagent and how it is used to distinguish between primary, secondary and tertiary amines. Next very important name reaction is Hoffman bromamide degradation. Then you have certain this all the, I can say, the case based question you can prepare. Reduction of nitro compounds using scrap iron, this is important question. Then solubility of aliphatic amine decreases as the molar mass increases, this is also important question. So children, these were the most important questions from the chapter amines, and I hope that you have understood all these questions. If you still have doubt in any of the question, do not hesitate, please let me know in the comment section, I'll definitely address to it. So thank you so much for watching and all the best for your pre-board exams. Thank you. Bye bye. Take care.